So, good morning, students. We'll start our topic number 6 of Unit 4, which is Corrective Measures, Basics of Modern Project Management Systems, that is a lean construction, that is LC. The first topic is corrective measures. So, the first corrective measure is using the construction management software. Using construction management software with data management capabilities helps keep everyone on the job site updated on any changes to the scope of the project. It helps connect back office staff with workers on the job site to ensure an active line of communication across everyone involved in the project. Number 2, regularly update cost plan. Consistently analyzing and re-evaluating cost plans. If costs are higher than expected in one aspects of the process, make sure to balance it out by reducing costs in another area. So external factors such as inflation or a shortage of materials can also cause prices to change, and therefore a project that may have been within budget before could now be over budget. Number 3, consistently submitting cost reports. Cost reports are essential to help streamline communication between owners, general contractors, and subcontractors. By updating management with real-time progress reports, example daily reports on a construction project, cost reports helps identify early on if any delays or unplanned budget overruns may occur. Number 4, prepare a new contingency plan. So by having set risk management procedures, project managers can plan for delays and budget overruns and have a set of plan of action on how to remedy the issues ahead of time. Contingency plans helps prevent having to pay premiums to get the project done on time when something goes wrong at the last minute. For example, construction management software can provide statuses of critical submittals, RFIs, change orders, etc. So which can signal the project has a bottleneck and unexpected significant delay about to occur. Number 5, encourage project team to design within the cost plan at all stages. Make sure you are following the design development control procedures. There is a general rule that 80% of the cost is determined by design and 20% cost and 20% by construction. So ensure each worker understands that construction plans are created per the total budget, and making changes could result in unplanned costs that exceed the projected budget. Basics of modern project management systems such as the lean construction. Lean construction is a method of production aimed at reducing costs, materials, time, and effort. Essentially, the methodology is to minimize the bad and maximize the good. Using the principles of lean construction, the desired outcome would be to maximize the value and output of a project while minimizing wasteful aspects and time delay. This outcome is produced when standard construction approaches are merged with a clear and concise understanding of project materials and information, and two sets of management archetypes, planning and control. So this may seem complex to understand, but the essence of this system to use what is necessary without extra. So this can only be done by strategic planning and action by a management group and with the help and aid of all the workers. In continuation, it should be understood that lean construction is a philosophy with principles and ideologies, but it is not a concrete plan of action with set of tools and methods. Lean construction principles are the same throughout the many different schools of thought, and the basic principles include creating a predictable atmosphere based on planning and data, reducing the overflow of waste from careful planning, and increasing the communication flows between the customer and the project at hand. Lean is a way of thought based on the notion that less is more. So, in the following sections, hopefully, A clear understanding of the principles and practices of the lean mindset are clearly expressed. The benefits of lean construction. Number one, using fewer materials and having less waste can greatly reduce all around cost. Although the philosophy of lean construction is focused on overall reduction, not just for profit, utilizing this methodology has shown to increase the bottom line. Number two, construction time can greatly be reduced by increased planning and strategic vision. Number three, fewer accidents and a higher rate of safety through increased worker focus and understanding. Number four, increase schedule reliability and predictability. Number five, improve overall results due to increased communication and fewer workers. Number six, decrease stress for workers and management due to fewer workers. Increase productivity all around due to higher rate of planning. Increase profits and turnovers with increased customer satisfaction. Increase worker accountability and increase job satisfaction resulting in more performance commitment. Next, drawbacks. Number one, in order for this method of lean construction to be effective, all areas of management along with the workers have to be in accordance with the plan. So if there is a break in the chain, the lean methodology cannot work. Getting people on board with a new production method isn't easy, and some people may be ambivalent about the change. In order for successful implementation, management officials must be able to guide employees directly and efficiently. In essence, the lean method of operation is derived by how well a management official can work with his employees, more so than with the standard procedure, and personality clashes as well as other issues may arise. Number four, training and educating employees in the lean method takes time and dedication, and as expressed earlier, some workers may not like or deal well with the change. Number five, staying on course with a new system of operation can be difficult for some managers, and some may grow frustrated as well. Number six, cohesive teamwork is essential for lean production. Each worker has to be well versed in his position, or a breakdown will occur as all workers rely on one another. Number seven, training employees with a new system can take some time, and this could decrease the overall time on a project or design. Number eight, management has to be astute to all production issues, as a breakdown in the system can easily occur. Staying alert to the change in operations can be hard for all the employees. Number nine, suppliers and distributors have to be notified of the change in production, and this could cause problems. And number 10, a temporary decrease in employee morale might be noticed due to the change in the policy. Next, how lean construction is different from the other construction methods. So, lean construction cycle, a project managed under the standardized view of construction versus that managed using the lean philosophy is greatly different. So, from the beginning of a project to the end goal, every area is drastically changed. One of the biggest differences is derived from the strategic planning of the lean philosophy. Lean construction forces all parties from the strategic planning of lean construction focuses all parties to have clear set of goals, benchmarks and objectives for the end process. So using the lean philosophy, the whole idea is to maximize the performance at every level for the customer. This includes employees, distributors and all managing parties. All of these groups are forced to work cohesively together and stresses production control throughout the entire project. Every unit of the project works together like a well-oiled machine, meaning that if one piece is loose, everything falls apart. Current construction models utilize the mass production mindset, meaning that every job is allocated to just one group with little or no interaction. The lean focus causes all parties to work as one, thus maximizing time and allows more efficient planning and implementation. The lack of predictability is the main problem in standard construction procedure. Unpredictability results in lost time, waste, and stress. The lean philosophy is centered around predictability and flow, and thus eliminating the most negative aspects. You can give your attendance now in the chat box. Thank you.
Construction in 3 minutes. What is lean? Lean is a system involving the continuing transformation of waste into value from the customer's perspective. It focuses on two linked steps: the continuous elimination of waste and in 3 minutes. What is lean? Lean is a system involving the continuing transformation of waste into value from the customer's perspective. It focuses on two linked steps: the continuous elimination of waste and the creation and flow of value, with waste without interruption. Lean construction is improving the construction process to profitably deliver what the customer needs. There are 7 types of waste in construction that Lean eliminates. Transport: unnecessary movement of materials or products that does not directly support immediate production. It should be minimized as much as possible, as it is not value-added activity, and the material will be exposed to handling damage. Inventory: supply in excess of what is required. Inventory includes raw materials, work in process, and finished goods. Excess inventory can quickly build up and tie up dollars and resources due to the additional handling and space needed. Motion: the extra steps taken by people to accommodate an inefficient process layout, defects, reprocessing, overproduction, or excess inventory. To move and add value is called work. To move and not add value is called motion. Waiting: waiting refers to the periods of inactivity that occur because of preceding activity didn't deliver on time or finish completely. Waiting waste increases cycle time during which no value-added activity is performed. Over-processing: unnecessary steps in operations, such as reprocessing, double handling, added communication, and double checking, which adds no value. Over-processing is often inserted into a process as a result of dealing with defects, overproduction, or excess inventory. Overproduction is producing more than is needed, faster than is needed, or before it is needed. This results in excess inventory carrying costs. Defects: products, materials, or services that do not meet expectation or conform to specification. Corrections and defects are anything not done correctly the first time and must be repaired, sorted, remade, or redone, as well as materials which are scrapped due to defects. The benefits of lean construction reach the customer, business, management, and staff. The customer gets a more consistent service, improved flexibility, responsiveness, construction time, product quality, and a lower total cost. Business has a better cash flow and productivity, reduced stockholding, improved asset utilization, environmental benefits, increased profit, and improved customer relationship. Management gains by better collaboration between design, general contractor, and subtrades, more reliable processes, less crisis management, improved staff flexibility and morale, and delegation of daily responsibilities. Staff receive improved safety and job satisfaction, greater ownership of work area, more pleasant work environment, less stress, and immediate feedback on their performance. For more information, visit www.
And then we'll start. A brief introduction to explain where do we start from, and then we'll pass on to the practical implementation of it. So the idea of implementing lean within the sustainability and within the green construction project field come from our research study that we did in collaboration with the Polytechnic University of Valencia and the Michigan State University. It focused on the implementation of lean within the green construction field. And the idea was quite simple because it came from one of the key concepts of lean construction itself. Cosquela in 1992 said that judging from the manufacturing experience, construction could realize dramatic improvements simply by identifying non-value adding activities. So the idea was to take out the waste from the processes. An idea that following a traditional approach of the green construction can be explained as follows. So you have a designer, you typically have a designer, a general contractor, or an owner that develops a project or a design and then gets some consultants to tweak the project or to adapt the project even alongside to the green needs. That's why we're called consultants. The thing is, the idea is that if we know there is some waste in this bit, how much more waste do we generate down the line? So the idea of implementing lean within this sector was to focus on that bit of the traditional process. And so we had this case study research. We got 4 real case study projects, one school complex, a nursing home, 2 office buildings, all in Southern Europe, 2 of them LEED certified, and 2 of them BREEAM certified. And by the end of the study, we developed a methodology, we validated, and by the end of the study, we focused on the results. So on how much waste did we detect within these green building processes. So these are the results. It's a very short table. But basically, the results in terms of waste, they were specified in terms of extra costs, so added costs to the original budget in order to pursue the green construction features, delays or extra time implemented for the same purpose, and loss of green construction features. You may want to take a look at the variance because you have some quite big numbers. We are referring only to the design process for these case studies, and there will be many considerations to make, but this is not the point. For example, the difference between implementing a design build rather than a design build process. The first one turned out to be much better than the second one. The huge benefits of implementing an IPD approach, the positive relationship between project management and green building features, and vice versa, and other results. We gathered all these results within what we call Green Building Factory GBF method, but the key idea here was to use lean only to detect the wastes within the process. Since this is not really the key of the point of this presentation, I leave you here some links if you want to take a look at the research study more deeply. We did a webinar for the LIPS Association in public sector, and it's free. You just go into their website, you register, and you get it's a 1-hour webinar where we explain all the outcomes. And for the GBF method, you have a link to our website. But again, this is not real the point of the presentation. This is just a starting point to start implementing lean within the green construction field. So now we are going to see how could be the practical implementation. Because after that we said, hey, how could we design better processes? How can we not just detect the waste, but avoid it from the beginning? And so we split this presentation in 2. One, practical implementation for services, and then will come the practical implementation for procurement. In relationship with services, we tried to develop a sort of IPD for sustainable construction. And it worked like more or less like this. Going back to what we just said, we have the standard approach where you have the designer, the traditional know-how of the project, and then the green building tweaks or the consultant. And this happens generally, or at least for the vast majority of projects that we see, for different types of services, like energy modeling, psychoanalysis, emission authority, thermal comfort modeling, and all. The problem is that throughout the process, the project development process, that I summarized using the RIVA stages, so from the initial idea to the concept design, technical design, construction, and use. These services are called in very punctual times, and they are generally provided by different suppliers. So you may have one supplier doing the energy modeling thermal comfort, the other commissioning authority, the other lighting, etc. And all these consultants are tied to the owner or to the general contractor with separated contracts. So that makes the process extremely fragmented. And the real problem is that whenever you have a problem, is always everybody else's fault. And so we try to solve that, creating what we call operation management team. We don't approach the project from the timeline point of view, but from the field point of view. Here is just an example: architectural design, mechanical, procurement, project management, structural, whatever. We know that the architectural design for a building, for example, can take place at the beginning, but then if there are major change orders during the construction, it may require an option later. Now, the idea is to approach the project from these fields point of view and having